So next in the inspection and testing series, we'll be looking at the low voltage circuit breakers. So we are going to look at the physical or visual inspection and also the electrical tests that we can carry out on these low voltage circuit breakers. So the low voltage circuit breakers that we'll be looking at, they include the molded case and then the insulated case circuit breakers. So now we have been supplied the circuit breaker, or the circuit breaker is one that is installed already. So we want to carry out a few visual check or visual inspection or visual check and electrical test on this circuit breaker. So like we said earlier, there are two basic tests that we can carry out on the circuit breaker, and they include the mechanical test or the visual test and also the electrical test or inspection. So we are going to look at the visual test first. So in the visual test, the first thing we need to do is to check the nameplate information. Okay, we check the nameplate information and see that what we have in the nameplate is as specified for that circuit breaker or for that particular circuit. So the basic things that we'll be looking at here, we'll look at the voltage, and then we'll also look at the current rating. Okay, the voltage and the current rating of the circuit breaker. That's the nominal voltage of the circuit breaker and the current rating of the circuit breaker. So this is a 250 amps circuit breaker. For us to appreciate the nameplate information of the circuit breaker properly, you can check the description below for a link to understanding the circuit breaker nameplate. So all of this information, what they represent and how you can use them to ensure that you have the right circuit breaker in the right circuit. Okay, so you check the nameplate information, then you compare that information with specifications or with the drawings. So the drawings will tell you the loading that will be on that particular circuit. Like this circuit breaker now, though this is a detachable circuit breaker, so this is 200 amps. Okay, and then when you look at the voltage of the bus is 480 volts. So which means that the circuit breaker that you will be using should be able to work comfortably in that environment, that is 500 volts or 480 volts AC. Okay, then the current rating, remember at that time we said is a 250 amps breaker. Okay, so which means that from the diagram, if this is the breaker, that means it is fit for use. If we don't have diagrams like this, we can also look at the specification to see that the right circuit breaker is specified for the right circuit, and that is what we have in the installation. Okay, so this is the current rating of the circuit breaker. Okay, so which means that a circuit breaker like this, if it is one that we can use in a 415 environment, circuit breaker like this, we can use it in okay, it cannot go into any of these circuits because all of these 200 amps, 600. Okay, but basically those are the things that you look out for to be sure that the circuit breaker that you are having will match or work in that particular circuit. So still on visual inspection, we want to look at the physical conditions. We want to look at signs for deterioration, signs of stress, signs of discoloration, and what have you. Okay, so if there are signs like that, we want to do all that we can to actually bring the circuit breaker back to what we feel is normal. So we want to also inspect the anchorage to see that the circuit breaker is properly installed. If this one is installed on a wall, the anchorage should be firm. If it is installed to the floor, the anchorage should be firm so that the circuit breaker will not have that chance of being displaced from its normal position during normal operations. So we also want to check that the circuit breaker is clean. If it is not clean, we can use the vacuum cleaner to vacuum clean and remove dust, okay, and debris. We know all of those can reduce the insulation between the phases and cause problem during normal operations. So we can circle the breakers, we can switch it on and off to see that it is working normally and smoothly. Okay, we can switch it on off to see that everything is working normally. So still on the mechanical or visual inspection, we also want to look at these bolted electrical connections. We want to look at the torque to see that the actual torque level is applied. Okay, so if we do not have one specified for our facility, or the manufacturer does not, for this cabinet does not specify anyone, you can check the table. You can check this table and then use this table, apply the normal torque value. The different bolt grades, they have different torque values. Okay, so as you can see, you can use this table to determine the normal torque value for all of these bolted connections. Okay, so you also want to check to see that there are no signs of high resistance. Signs of high resistance will show off as maybe having a metal oxide deposits, those greenish or whitish substances on these joints. So those deposits, they are clear signs of high resistance, and those can cause hot spots on the circuitry, which we do not want. Okay, so we can use low resistance ohm meter to determine whether we have a high resistance joint. Okay, after cleaning, we can place one probe of the low resistance meter here and then the other one on the bolt to see that the bolt and the bar, they are making proper connection, that the resistance is as close to zero as much as possible, zero preferable. So that is what we want to do on all of these bolted connections to see that no resistance is building up. Okay, so we can use the torque wrench, calibrated torque wrench, to tighten those bolts to see that the appropriate torque is applied to those bolts. Then we can also perform thermographic survey. During the thermographic survey, you would have allowed the equipment to be loaded for some time, that is in operations for some time, so that all of these bars and these conducting bars, they would have been heated up by the flowing current. Okay, we'll load them as much as we could. Then we'll take the thermographic survey to be sure that we do not have any hot spots on the circuitry. So if you are not too familiar with thermographic survey, you can check the description below for a link to a video on thermographic inspection on electrical circuitry that will give you an idea of what it means to carry out thermographic survey. So this is the table that shows the torque value for different grade of bolt and for different sizes of bolts. Okay, so these are the torque value for this grade, torque values for this grade, torque value for this grade, and for different sizes of bolts. Okay, so still on the visual and mechanical inspection, if it is possible to open the breaker, you can open it as you can see. Then you inspect the operating mechanism to see that it is functioning properly. Then the contacts, you need to look at them to see that they are free from debris and other metal oxides that are deposited, that will be deposited on the contact. If there are, we clean them. Then the arc chute is also free from contamination. This is the arc chute, okay, that they are free from contamination. So the function of these various parts, you can also check the description below for the operations of the circuit breaker and various components of the circuit breaker. So the link to the video is in the description below. So once we have done that, we can perform the necessary adjustment. And as we are performing the adjustment on this setting, we need to also put into consideration other breakers that are upstream, or other protective devices that are either upstream or downstream. So we want to coordinate this or set it in accordance with the coordination study of that particular installation, coordination and short circuit study of that particular installation.